Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vectors in R squared. So as per the problem, parallelogram OBCA is determined by the vectors OA, which is equal to 6, 3, and OB, which is equal to 11, -6. So in part A, we have to determine vectors OC, BA and BC. So the first step is to sketch this given parallelogram OBCA. Now in this parallelogram, point O represents origin. So that's 0, 0. Now for B and A, we can use these given position vectors to find their coordinates. So for point A, the coordinates are 6, 3 because the position vector is equal to the coordinates for the point. Similarly, point B is 11, -6. Now we can use this information to sketch the parallelogram. So the first point is the origin. Now we can show point A. So that will be somewhere here. And then point B, and that will be somewhere here. Now the given parallelogram is OBCA, so we'll have to go in that order. So we'll start from point O and go to point B, and then from point B to point C. Since we do not know the coordinates of point C, we know that point C will be somewhere here, because in a parallelogram, opposite sides are equal in length and parallel to each other. So if point C is somewhere here, then side BC will be parallel to side OA and have the same length. So I think point C should be a bit closer to B. Yeah, maybe here. And now we can complete this parallelogram. So this is parallelogram OBCA. Now in part A, we first have to find vector OC, which is the diagonal of this parallelogram. So this is vector OC. So vector OC goes from point O to point C. Now an alternate way to go from point O to C is to go from O to B and then from B to C. So vector OC is equal to vector OB plus vector BC. Now we know that in a parallelogram, opposite sides have equal length and have the same slope. So that means vector BC is equal to vector OA. And we know the values for vector OB and OA. And we can add these vectors by adding their x components and y components. So this is vector OC. Now we can find vector BA. So we can break up vector BA into its position vectors. So we'll start with the second letter and then minus the first letter. And we are given vectors OA and OB. Now we can subtract the vectors. So 6 minus 11 is equal to negative 5. And 3 minus negative 6 is equivalent to 3 plus 6. So it is equal to 9. So this is vector BA. Now we can find vector BC. So for vector BC, we can break up BC into its position vectors. So we found vector OC as 17, negative 3. And OB is given as 11, negative 6. Now we can subtract the vectors. So 17 minus 11 is 6. And negative 3 minus negative 6 is equivalent to minus 3 plus 6, which is equal to 3. So this is vector BC. So we are done with part A. Now we can analyze part B. So in part B, we have to verify that vector OA magnitude is equal to the magnitude of vector BC. So let's start with the magnitude of vector OA. So vector OA is given as 6, 3. So we'll square the components, add them and put the sum under the square root. Now 6 square is equal to 36. 3 square is 9. So magnitude of vector OA is equal to square root of 45. Now we can find the magnitude of vector BC. So we'll square the components. So vector BC is 6, 3. So 6 square is 36. 3 square is 9. So I got square root of 45. So that means the magnitude of vector OA is equal to the magnitude of vector BC. So this should be the final answer for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.